Carol, can you hear me? Yes. Yeah, good. Yeah. So maybe we can switch off to the present screen.
Yeah.
Okay, hey, good morning everybody. Welcome to the second lesson of the Geo-Python course, also together with the Automating GIS Processes course. So we would like to start by asking how was week 1? So if you want to say something, please feel free to do so. Also go to geopython.github.io/poll. So we have 2 questions there. Firstly, what did you learn? If you learned something last week. And then there's a second question, if something was unclear, so we can also discuss those points together here if there's some pattern. Basic Python syntax, how to use CSV notebooks, coding, variables, first insights into programming.
Yeah, important insights.
Yeah. So indeed the point of the first week was to get everybody started with Python, writing a few lines of Python code. And as we have indeed, as somebody said, there were so many places to sign up. That's true, but then from now on we'll be using those environments hopefully to work more efficiently. So we have the CSV notebooks environment, Binder, also maybe Slack, GitHub. So those are the main environments and tools that we'll be using to communicate and work during this course. And then also some of you have installed Anaconda and Python on your own machines. How did that go? Was there some problems? So if you want to do that, feel free to do so, and you can ask for help maybe mainly in the exercises then, because there's different operating systems and such for that. Okay, and maybe we can check, if there were some problems.
Text is a little bit small here, so we can make that a bit bigger.
Okay, signing up to many websites, how to find information, different pages, different places. Finding where to download the notebook. Yeah, so that was one issue. We kind of intentionally did not provide you print screens on how to download a file from the browser. So I think most of you managed to do it, and those of you who ran into problems hopefully asked for help. And indeed there was some problems if you were using Binder on Chrome browser for one reason or another. You might not have been able to download the file. If you ran into such problems, you can contact us. We can then find ways for you to submit the exercise anyway.
The other thing maybe here that's sort of important is the file type when you do the download. So it's not necessarily intuitive that the Jupyter Notebook is a .ipynb file. So it's an IPython notebook was the former name of what Jupyter Notebooks were called, and they kept the same file extension. So when you download a Jupyter Notebook, it's an IPYNB file, and I don't know, maybe we can indicate that somewhere on the web page so that you know for the exercise we can.
We'll go through a bit more in detail the contents of a GitHub repository or our exercise repository. So you always have the readme.md file, which is a markdown file, and then at least one or several Jupyter Notebook files, and then today we'll start using Git, so then you'll have some hidden photos related to the version control system. But indeed the things in the first week were quite easy, but the point of this course is to also welcome very big beginners, so some of you have programmed before, so these maybe first weeks might be a bit simple. Let's say starting from week 3, based on previous year's experience, it will be quite busy in the exercise sessions. So do you have any more specific questions on the programming in week 1 exercise? Maybe I could show one thing. I think we have Jupyter Lab here open.
We do.
I'll just go ahead and maybe demonstrate some things in a Jupyter notebook. So you were supposed to create your own notebook, do the programming exercises, and then download your files. And then there was this one optional task for kind of combining your names. So just quickly, if I would type in my name, for example, maybe first.
A bit bigger, sorry.
Yeah. And then underscore is that.
Yeah.
That one. No, that one. Let's run that, and then I would have my name. Okay, so we'll also revisit this in today's class, but some of you figured out that then you can actually combine or concatenate, kind of glue together different pieces of words by kind of summing them up. Let's do that. But of course, if you do that, we have the first name, it ends with an O, then the last name starts with an H. If you put those together, then you get them all in one pile. Then of course you would need the space in between as a character string, so we can add a space in between, and then you'll get the full name. So that was something that we checked with some of you in the exercises, so just to share with everybody. Okay, maybe we can then continue with this week's lesson.
Yeah, so let's do just that. I'm going to start here just quickly by taking a look at the lesson overview on the course website. So it looks like the version I've got loaded now needs to be refreshed, but you should see now that lesson 2 is visible. So if you go to the course site, you can go here to lesson 2 and to the overview, and just to see what we're going to talk about today. We'll continue with some basic stuff in Python, so following up on what we did last week, in fact, kind of going back to the idea of data types and things like that to start. So this basic elements of Python, we'll talk about data types, converting from one type of data to another, and also another thing we didn't see last week, which is a list in Python. So we'll talk about how to make lists, what they can be used for, and things like that. We've got another good coding practice about describing your code. So we'll spend a few minutes talking about adding comments and other things to help people read your code a little bit more easily. And then I think sometime around here we'll have a break, and then we'll continue in the second part of the lesson with talking about version control and GitHub and how we'll be using these things during the course. So if you don't know the first thing about Git or version control, that's not a problem because we'll introduce it today. And I would think by the end of the course, you'll have a decent amount of experience with using GitHub and Git, and those are both tools that are pretty widely used by people who write software for their job. And then, of course, like we typically do, we'll end up by taking a quick look at the exercise for this week, just going over what you'll be doing there and introducing that. So that's where we're headed, and we're going to start here with this basic elements of Python. To do this part of the lesson, we'll be doing it kind of how we have last week, where you're following along in a notebook. So if you haven't gone yet to the CSC notebooks system, you can go there. Yours won't look like this because you have the nice looking version that doesn't have all this extra stuff. But if you go here, you can open up a Jupyter notebook, and we're going to get started here in the notebooks directory, and then inside there, notebooks, and then L2 for lesson 2. There's only one notebook in there, I believe, and that's this Python basic elements. So yeah, if you have any issues with getting the CSC notebook system open, getting your Jupyter notebook running, there's
Just a side note, somebody's saying that YouTube stream audio is a bit quiet. I don't know if there's something.
the audio is a bit quiet. Okay, well, I can try to see if I can bump the audio up on here. Input. I'll bump this up just a little bit. Okay. Maybe that's a bit better. I don't know. It'll take probably 10 or 15 seconds before somebody actually knows whether it's working. Anyway, yeah, you can go ahead and open up this Python basic elements notebook here, and I'm going to get this file browser thing out of the way so there's a little bit more space here and so you can see a bit better. So as I mentioned in the lesson, we're starting out here with data types revisited. So last week we talked a little bit about assigning values to variables and how different variables have different data types. And you should see in your notebook that you have the first 5 cells here with text or code already there present. This is some information from the Finnish Meteorological Institute's observation station website. So this is information about the Kaivopuisto observation station, and you can basically just run all these cells without editing anything. So you can just click on the cell, hit Shift Enter, and just go down and run the first 5 cells. The reason for this is that we didn't want to make you guys just type in this information. You don't really learn too much from typing in this kind of thing. But you can see here that we're assigning values to 5 different variables: station name, station ID, station lat, station lon, and station type. You can also see here that we're continuing the theme from last week with this pothole case variable naming. So we're doing station underscore name, everything in lowercase. And again, that's one of the good practices in terms of the types of names you can give to variables. But we've put in some information here, and now we're going to investigate a little bit further about what is stored in some of these different variables. So as a reminder, we can check the type of a variable in Python by using the type function. So if we just type in here type, and then some variable name, we can start with station name. So station underscore name. And if you run that cell, it comes back with str. So this is a character string. Just to remind you, if you look back up to where station name was assigned, you see that indeed within the quotation marks is some text here. So yes, this is a character string variable. If we do the same thing then, for instance, for station ID, so type and then station ID, you can run that cell, and what you'll see here is that the type of variable in this case is an integer, or int, meaning it's a whole number value. It's not a decimal number. And of course, if you look at station ID, sure enough, that is the case. It is a whole number. And finally, if we look at the type of, I guess, station lat, could also check station lon. That's the only other kind of variable we have assigned in this case. And this is a floating point or a decimal number value. So float is the type that comes back there. And sure enough, we see 60.15 for the station lat data type. I don't think we talked much last week about why knowing the data types is important, but it does make a difference because some kinds of data, certain types of data in Python are compatible with one another and certain types are not. So what we saw is our character string, integer, and floating point numbers. Some of those things can go together. An integer and a floating point number you can combine, no problem. But if we did something like this, if we tried to add together station name plus station ID, we're going to have some trouble because Python doesn't know what we're trying to do. Are we trying to do mathematical addition? Because we do have one number, station ID. Are we trying to add that to some other number? Well, Python doesn't know because station name isn't a number. So these two data types are not compatible with one another. We get a type error in this case which says the data types are not compatible. And the message that comes with this type error is that you can only concatenate strings, not an integer and a string. So we saw that actually when Vuoko showed the example of putting first name and last name together. You can do a plus to concatenate strings, to put 2 bits of a character string together into a single character string. That's not a problem. But you can't concatenate a string and a number. And if we flip these things around, so if instead of saying station name plus station ID, if I just flip this around and said station ID plus station name, I'm going to get a type error again. That's not a big surprise. But I get a little bit different error message here for the type error that says unsupported operand types for plus, int and str, str. So what it's saying here is I want to do math, I want to add these things together, but I can't add a number together with a string. So whenever you see this kind of type error, that should be something that clicks on in your head right away to say, we've got data types that don't work together. If I wanted to add together station ID with, instead of station name, something like station lat, no problem. 2 numbers, we can add them together. It doesn't matter that one's a whole integer value and the other's a floating point number. Those things are perfectly compatible with one another. But you can't combine things like a number with a string, at least not without doing something additional. Likewise, if we said we wanted to take, for instance, station name and add that together with another string, so we have the station type that's given up here as a string, we can do that without a problem. So we could here do station name plus station type. Python will say, okay, we've got a string plus a string, and those 2 things can be put together. This isn't very nice looking output here, of course, but the data types are compatible. So that's the reason why this data typing actually becomes important, because sometimes you will have cases where things just don't work together. Now, what happens when you want to do something like take a number and add it into a string so that you have some kind of longer character string that contains both some text and a number value? Of course, we can do that. And the way that we can do that is by doing a conversion of the data type. So we can make a new variable here called station ID str. So we're just going to go ahead and indicate that this is going to be a string variable just by adding the str to the name. And we can use a function that's built into Python called str. It's a function that converts numbers to a character string. And if our string we say station ID, that previously was an integer value, we can run this cell, nothing gets output because we're doing an assignment to this variable station ID str. But if we check its type, so type of station ID str, we see that at least one of the things has worked out nicely, that we have converted our station ID to be a character string data type. And if we print out the value of what this station ID str is, we now see basically the same thing that we saw before, this 132310, but we know it's a character string now. And actually, if you, instead of printing it, if you just type in the name of the variable, and run the cell like this, you then see the quotation marks around that. When you print it, the quotation marks get kind of taken away in the text that's displayed here. But you can see here clearly that this is a character string from the quotation marks around the number. So the same information is there, it's just now stored as a different data type. So I guess that makes sense? Yeah. Well then, we've come here to our first polling question. I guess Volko, is it already set to go? Okay. So we're going to pause here. We've got 2 questions for you. And if you go to the polling page for the course, you should see those visible there now. And we'd ask that you take a quick look at the poll questions there, fill in your responses, and then we'll take a look at what we've come up with. I'm going to put this over onto, oops, there we go. Zoom out just a little bit so we can see. So yeah, the first question here is just about selecting the output you expect when you execute the following. Print station ID plus station lon. So just fill in what you think would happen if you were to type this into your Jupyter notebook and run the cell. All right, we're doing pretty well here. I think we've got almost only 4 people left that are online who have not yet responded, so that's very good. And yeah, what we can see here is that there seem to be kind of 2 leading answers. One is has about twice as many responses, and that is that you'd expect to see 334.96, which would be the combination of the whatever it is, 132.310, which is the station ID, and the station longitude, which I don't remember what that is, 24.96 maybe. And then the other is that we would have a type error. As it turns out in this case, the winner is correct. So in here, with 31 responses, the correct answer is that we can easily add together an integer value, station ID, and a floating point value, station longitude, because those 2 data types are compatible for this operation of addition. So when we have station ID plus station lon, no problem. One's a number, the other's a number, and you add the values together and you get the result. The result that would come out here in this case would be a floating point number, so that's not maybe a surprise. Whenever you add an integer to a floating point number, you're going to get a floating point number back. If you add 2 integers together, it remains as an integer, but if you add that floating point value, you get a floating point value back. So yeah, any questions about this? I guess this is perhaps clear in this case. So then we have a second question, and I think our remote control. So second question here is that if we now consider a second case, what happens when you type print station name plus station ID str? And again, this is just a question of what kind of output would you expect to see written to the screen in this case. And it looks like everybody, or a good number of people, have already been here and responded. So I'll give you a moment, although I suspect from the number of people available to respond, we're not going to see the vote swing in any meaningful way in this case. So it looks pretty clear that what's going to happen here is we should see Helsinki Kaivopuisto, 132310, and indeed that is what we would expect to see here. So station name, again, is Helsinki Kaivopuisto, and there is a space between the two words there, but then there should be no space between that and then the converted station ID, which is now a character string. So before, when we tried to add those things together when it wasn't a character string, we had this type error. Once you convert station ID to a character string, we now have one string plus another, and those two things will be concatenated or added together in the form that happens with strings in Python. This is kind of a neat thing because there aren't so many other languages I can think of where you add character strings together like this. So this is a handy thing to be able to do in Python to make nice looking output. So yeah, well done. You guys have seem to be learning a thing or two about the data types here in Python. Any questions about the data type stuff? I think we're going to move forward from here. Okay. As a reminder, if you're not up to raising your hand and asking a question here, you can always post questions in Slack as well. So we've got one last thing to talk about here with the topic of data types before we move on to lists, and that is that in cases where we want to combine text and numbers, we can do the same type of conversion that we did before. We've actually seen this example already, or something very similar to that, and that is if we said we want to have station name and ID, well, we can make a new variable here called station name and ID. And in this case, we can take our station name and we'll make this look a little bit nicer. We'll add some text in here between the quotation marks, just a colon and then a space after that. And then we'll add str of station ID. So this is just to demonstrate that in the last example for the poll, we saw the case of adding station name to station ID str that has been already converted. You can also include the conversion to a character string within the assignment to the variable. So station name and ID is just going to be station name plus this colon space, and then the string function or str function of station ID. So if we assign that and then print out our variable station name and ID, you can see that indeed we can do the conversion like this, or we could have taken station ID str and added it in there as well. There are other options here. I don't recall whether it's mentioned. Yeah, it's actually mentioned in the note above this section that if you want to convert like a floating point number to an integer or convert an integer to a floating point number, there are also data type conversion functions for that. So we can convert numbers to strings, but we can also convert numbers to different types. And yeah, that's worth noting here because there may be some instances where you want to convert something to be a floating point number or an integer for one reason or another. Although you have to do that a little bit carefully because the integer conversion will just drop everything to the right of the decimal place. So it's not necessarily a nice thing when your 2.99999 gets converted to the integer 2. So there are rounding functions that can be used if you want to round the numbers. The integer conversion just drops off the decimal place and everything to the right. All right, so that's the kind of quick look at the data types, and now we can move on to our, I guess it's kind of the main topic for today, and that is lists and indices. So in Python, there's there's a group of different kinds of data that can be used, or types of data structures that can be used to store collections of values. And the simplest one in Python is called a list, and that's what we're going to see today here. In this section here on creating a list, we have our first list here already defined for you. So we've got a variable here called station names. And in this, you can see that we've got an equal sign, so we're assigning values. And we've got a group of things in text that are enclosed within the square brackets. So we've got Helsinki Harmaja, Helsinki Kaisaniemi, Helsinki Kaivopuisto, and Helsinki Kumpula. These are 4 different FMI station names, and if you run this cell, we can assign those to the variable station names. And we can print that out to the screen. And what you should see basically is exactly what we just typed in. Square brackets and then values that are separated by commas. If we check the type of station names, so again, just use the type function and station names, we can run that and see now we've got a new data type. So we've seen string, string, float, integer, and I guess we haven't really seen Boolean values, but we mentioned there's true and false values as well. Now we've got another data type here called a list. So in our list, we have these 4 station name values, and the way that we've assigned or indicated that we want to create a list is by putting things within a square bracket, and then the values in the list are separated by commas. So it's a fairly intuitive thing to create. Something that's perhaps a little bit less intuitive are index values, and it's not to say that they're a hard concept to understand, but it seems to be something that every year is a bit challenging. Within the list, if we want to refer to a certain value, we have to use something called an index, and the index is basically just a number that says which position within this list am I trying to find a value. So if we wanted to say, let's check the first value in our station names list, we could look at station names and then our square brackets 1. So this is going to the position 1 in the list, and it will find whatever value there is in station names. And if I run this, I get Helsinki Kaisaniemi. And of course, this is a deliberate mistake to make in front of you. The idea here is that what you see is not actually the first value in the list when you look at index number 1, but instead we get the second value in our list. That's because Python, like many other programming languages, starts with index 0 as the thing that would be the first value in a list. So if we actually want to get the first value in station names, we would want to type in station underscore names, then our square brackets, and 0. So whenever we give the variable name station names with the square brackets and a number inside there, that's an indication that we're trying to find a value within this list called station names. And the first value lives at index number 0. This will take a little bit of practice to get used to because it's a very common thing to get mixed up and think, okay, I want the third value in my list. I'll use index 3, but then you get the fourth value that way. And it's just something that I think takes some getting used to. So we can find the first value in our list here, Helsinki Harmaja, by looking at index 0 in station names. Now, we can tell you that the index value idea is something that's not going to show up only in today's lecture and forever disappear and not be important to you. It's actually going to be something that comes back pretty regularly in the course. We'll start using other kinds of collections that are different than Python lists, but are essentially working in the same way, where you need to give an index to look up a value inside the list. And so it might be useful to think about something that's maybe more familiar to you than Python lists themselves might be. And for this, we have the glorious bill. So I've spent countless hours with Photoshop here, creating Bill. And I guess I want to try to make it so we can see all of Bill because he's too big for the screen. All right. Well, hopefully you can see Bill on your own screen.
Maybe I can do this to make more of Bill visible. Okay, so Bill's a glorious vending machine. And I guess all of you are at least somewhat familiar with the idea of how vending machines work. Bill's a pretty simple one. There's only 6 items you can select. And so you have here a lollipop, a cookie, a cheeseburger, a taco, ice cream, and a nice mug of beer. If you were to go and try to use Bill, you would of course have to insert your money because Bill is after the money after all. And once you've put your money in there, then the way that you would go about selecting which item you want would be to push one of the buttons over here, 0 through 5. So in this case, just like a Python list, Bill is a vending machine where the first item that you would select is at position 0, second one is at position 1, third is at position 2, and so on. So if you were to say, okay, I really want a taco, you could see that it's the 4th thing here, but you know that you have to push button number 3 to get the taco to come out of the vending machine. You could then ask yourself the question about whether you really want to eat a vending machine taco, but that's sort of beside the point here. The main thing is that these numbers that are listed here are basically exactly the same way that index values work for Python lists. So you have inside the list the values, the different things in there, lollipop, cookie, whatever. These could be station names. If we wanted to make this more boring, we could put, different meteorological station names in here. But these are the items in the list, these different food and drink items, and then their index values are the numbers that you would use to find those items. So in the future, when we encounter exercises where you get stuck and you're confused about how to use index values, what they sort of represent or what they mean, you can hopefully think back here to Bill and say, how does Bill work? Okay, now I remember how to use index values. I think once that kind of clicks in your head, it makes life a lot easier in thinking about some of the things that we'll be doing later on in the course, because using these index values to select a range of things out of a list and things of that nature is pretty powerful, and it's pretty helpful. So yeah, that's the kind of just the analogy that is Bill. And if you have any questions about how Bill works, I would be happy to answer those. Okay, so everybody gets this idea, and it's, at least as far as vending machines go, it's pretty simple. When you get to the exercises, you'll maybe go like, oh, wait, index values, I don't remember. So yeah, so let's move on a little bit further here with our list ideas and see a few other things that we can find about a Python list. Something you probably want to be able to know with your lists, or often want to be able to know with your list, is how many items are in my list. So for this, there is a built-in function called len. It's a sort of short version of length. And with len, you can put in some list. In this case, let's do station underscore names. And if we check the length of station names, we get back 4. If you remember from earlier in the lesson, we of course put in 4 different station names to our list, so this looks fine. Now you might be tempted to say, okay, well, we've got 4 items in our list, so let's go find the last item in our list by typing in station names, spell it correctly. 4. Say I've got 4 items in the list. That's easy. You could imagine if you had a list that had more than 4 items, this becomes, a little bit more tempting. If there's 50,000 items in your list, you might just want to take the length and plug it in here to find the value at index number 4, but you will get an index error if you try to do that. Probably most of you are thinking, yeah, of course you'll get an index error, because this index, number 4, is outside of the range of the index values for the 4 items in the list. So if we think back to starting at 0, we have 0, 1, 2, 3, and 3 should then be the index value for the last item in the list. This is something that's a little bit frustrating sometimes, because you would like to be able to take something like the length of the list and plug in the length of the list function here, like len station names to find the last item in the list. But of course that doesn't work because len station names is going to give you a value of 1, or sorry, value of 4. So you've got to subtract 1 from that, which is kind of a clumsy looking way to find the last item in your list. Of course, there is a better solution for that problem. And this is something I think is also pretty cool about Python and Python lists, is we can take our station names here and put in negative values for the list index. If you put a -1 in here for station names, it gives you the last item in the list. It starts going backwards through the items in the list. And so we see here Helsinki Kumpula. We haven't seen this list in a while. It's somewhere up here, but Helsinki Kumpula is indeed the last item in that list. So we can use this negative number thing to allow us to go backwards through a list. I guess actually at this point I was supposed to print out the station name so that we could see that without having to scroll up. But anyway, we've seen that now. We could also put in station names and then -4, and this is okay because we're going to go back through the list. -1 would be the last item in the list, -2 would be second to last, -3 would be third to last, -4 would be the fourth to last item going backwards through our list. You probably don't want to go doing things this way necessarily, but this trick for finding the last item with -1 is something that gets used pretty regularly. Indeed, -4 is fine because, again, if we start at the bottom of the list with -1 as the index, then the fourth item going backwards would be -4. We can run into trouble though if we try to keep going. So if we say like, let's go to station names -5, if you try to do that, you'll again get one of these index errors because you've gone from the bottom of the list, you're going up, and then basically you run out of things by the time you get to index -5. There is no item before index 0 in our list. So I'm probably getting you kind of mentally head sort of messed up by thinking about this, but if we're going backwards, you can only go up to the first value in your list. You can't keep going backwards from there, or you get an error message that says your list index is out of range. So we've seen lists here kind of briefly. We've met Bill, and now I think we have the opportunity to take a look at another poll question. It should be all set to go, I believe. So you can turn your attention now back to the poll page here, either by clicking on the link or going to, if you've got another tab open with it already. And I'll flip over here. People are already ahead of me, so I think that's not necessarily a bad thing. But okay, for our list here called cute animals, we have bunny, chick, duckling, and kitten, and puppy. And the question is, which animal is at index -2? And yeah, I think with 49 responses here out of 54, again, things aren't going to change very much here. Indeed, kitten is going to be the item or the value that's at list index -2. If we go backwards through the list, -1 is puppy, -2 is kitten. And of course, if we're going to do cute animals and something that's on the internet, kitten is always going to win. So that is what we would see in this case. If you want to copy paste this into your Jupyter notebook, you can demonstrate that for yourself. But yes, so good. Everybody's kind of following this index value idea here so far. Now let's take a look at a couple other things about our lists. Lists are one of the data types in Python that are called mutable. It's sort of a funny word, but what it means is that it's a data type that can be modified once it's created. So we can take things like a list here of station types. So these are the station types for the 4 stations that we had in our station names list. And in this case, all 4 of them are listed as weather stations. This cell is already filled in, so you can run that cell to fill in the list station types with weather stations, weather stations, weather stations, weather stations, and then print it to the screen, and of course you see the same thing that was just typed in. What was useful here, combining the idea of the index values and the fact that this is a data type that can be modified, is we can take something like station types at index 2, so the 3rd value in this case, and change it to be a Mario graph or Mario graphs. And then after that, if you want to go ahead and just print out station types in the same cell, that's a useful thing just to see that our list has in fact been modified. So we're going to change the 3rd value in the list here by using the index value, assigning a new value to it, and when you run this cell, we now see weather stations twice, Mario graphs, and then weather stations once again. So that's nice because that means we can modify the values inside of our Python list, and that's a pretty common thing to do when working with this kind of data. And indeed, in order to do that, we have to be able to provide an index value for where we want to make the modification. We can also include in our list more than one kind of data. So the list itself is a list data type, but then there's values inside the list, and the values inside the list have their own data type. So let's take a look at that here with our data types in lists example. Again, we've given you the cell with the text already in it. So now we're going to have information just about the Kaivopuisto observation station. So here we'll have the station name, station ID, latitude, longitude, and station type, and we'll put them all into a list called station hell Kaivo. And what you can see when you print the list out is that just like we saw previously, we actually have different data types here. So we have some things that are in quotation marks, so these would be character string values, some whole numbers, and some decimal values. And what we can do is confirm that or take a look at the different data types by using the type function. So if we check the list itself, so station hell Kaivo, of course here we see that the list we just created is a Python list, no surprise. But if we look inside the list for station hell Kaivo, for instance, at index 0, it's the first item in the list, we have here the station name. If we check the type of the station name, we get back that it's a character string. That's perhaps not a big surprise, but this is interesting. If we check the station hell Kaivo item at position 1, index 1, here we see the data type is an integer. Again, that looks consistent with our list that was created here. The second value is an integer value. And lastly, if we check the type of if you're smart, you'll be copy pasting this rather than typing it in over and over. But here, if we check the value at index number 2, we see it's a floating point value, which is what we expect for the station latitude. So this is a useful thing just to recognize that Python lists are kind of neat because you can put different types of data inside them. All the data in the list does not need to be the same data type, and that's not true for some of the other things we'll see in other parts of the course. There are other structures where they all have to have the same data type. Here we can have a mix of different data types, and in fact, if you want to put Python lists inside your Python list, you can do that as well. So essentially, almost anything can go into a Python list, and that makes them a nice structure as a result because they're very flexible. So yeah, any questions about that? That seem intuitive? Yeah. Now, a couple other things about lists that we can look at here. So if we take a look back here at our station names list, I'm just going to print that to the screen. at this point, so we remember what's there. We have these 4 different stations, and we can use a built-in, it's not really a function, it's sort of like an operator called del, to remove values from a list. So we could delete, like if for some reason we said we only want stations that start with the letter K, we could delete this Helsinki Harmaja because it doesn't fit the strict criteria that we have here. So station names, and it of course is the first thing in our list of station names, so at position 0. If we type del and then station names at position 0, we don't get any output, so we need to print the list. So we print station underscore names, and then we see, in fact, yes, that we have removed this one station from our list of stations. I'll say at this point, if I'm typing too quickly, feel free to say something, but it seemed like everybody's mostly following, so I'll try not to get too far ahead. So yeah, we can remove things using del. If we want to add something, you might think, oh, cool, there's probably an add. Nope, it's a little bit different. So if we want to add something to a list, we have to use a slightly different format, and that is here we can do station underscore names, and then the thing that we want to add to the list. So here we've got this Helsinki Lighthouse and then Helsinki Malmi Airfield stations that we can add. So let's just type in Helsinki Lighthouse, or copy paste. So I got to add one more thing here, and that is what we actually want to do with it, and that is append. So this dot append is something, it's called a method. It's an operation that can be applied to certain types of data. This is something that works on lists. We'll talk about this idea a little bit later in the course about what these kind of things are, but station names dot append will then allow us to add an item to a list. And station names, we can do this for the second item, station names dot append. So Helsinki Malmi Airfield. So same thing there. At this point, it's useful to maybe print out station names as well. I'm going to actually do this in a separate cell, so I'm just going to add a Python cell here so I don't put in the Malmi Airfield thing, appending it again. So if I print now what my station underscore names looks like, I now see, yes, we lost the Harmaja station. Now we've got Kaisaniemi, Kaivopuisto, Kumpula Lighthouse, and Malmi Airfield. So there's our 5 stations now in our list. So cool, that works. It's just important to recognize that del is how you remove things and dot append is how you add them. We won't necessarily do this very often, but it's something to note that it is a little bit different whether you're adding or removing items from a list. Was there a question?
Yes. I was wondering, we can delete from whichever position, right? But can we also add to whichever position? Like, could we are deleting from position 0, could we add to that same?
Yeah, that's a good question. I don't think there's a way when you do append, it always goes to the end of the list. There are other ways to reorganize things once you have your data in the list, but when you add something, as far as I know, there's not a way to say you want to add it to a certain position. I think append will always just add to the end of the list, and from there then it's up to you to kind of move things around. Yeah. Yeah.
Maybe as a comment later, we'll learn different data types where you can then add things directly to those places which you want.
Yeah. Yeah, so just for the sake of if anyone actually is listening to the stream, that there was a comment from the other instructor Vuoko that with other data types we may be able to add into certain positions in the structures, but at least for the Python list it's always to the end. Yeah. Unless somebody knows a trick, I'm not aware of a way to to append to the middle or something like that, or to a certain position. Okay, so we've seen we can do this dot append thing with Python lists. Cool. If we have our we have our dot append approach, we can try and do something different here. So let's take station name and length, make a new variable here called station name length, and this is just len of station underscore names. So we've added these two values, we've subtracted 1, so 4 plus 2 minus 1 gives us 5, so that's what we expect to see here. So if we assign the length of station names to this variable called station name length, we can print that out. Station name length. And here we see 5 as we would expect. And just as an example, we can see what happens here if we take our station name length, which is an integer value. We can check its type. So station name length, getting to be kind of a long variable name to type in. We see it's an integer. And if we try to do station name dot, or station name length dot append, and then maybe the number 1, we're going to get here something that's an attribute error. Now, of course, appending 1 to another number, you're probably already yourself going like, why would you even want to try to do that? The point here is that this dot append thing is not something you can do to every type of data in Python. It is specific to certain kinds of data, including Python lists. So you can append values to a Python list. You can't append a value to an integer. You can't append a value to a floating point or character string number. There are other ways to do some kinds of operations if you want to add numbers together or make your character string longer or whatever. But this dot append thing is something that's specific to Python lists. So I'm just mentioning that here so that you're aware that this is not a kind of universal thing, but it's something that's linked to the data type. As I mentioned, we'll come back later in the course to the idea of objects and object-oriented programming. At least very briefly we'll talk about that stuff. And this is part of the idea that certain data types have certain operations that they themselves can do to themselves. So I think consistent with years past, we're starting to run out of time at this point for this part of the lesson. I'll show you a couple other list methods quickly, and then we'll take a break so that we have time to go over the Git stuff and also take a look at the exercise for this week. So these other things that are kind of interesting is there are ways to search within your lists and find out how many times a given value is present within the list. So these are some of these other kind of things that can be applied to lists. So if we take our station names list, we can do .count, and then in here put some item we'd like to look for in our list and see how many times does it occur within our list. So in this case, we'll type in Helsinki Kumpula, because that is one of the stations that should be present in our list if I haven't broken things. And sure enough, when we run station names.count Helsinki Kumpula, we get back there's one occurrence of that within our list. So that's a useful thing if you want to go searching through your list and say how many times does a given value occur. You could do that. If we were to look for instead, count of Helsinki Kumpul, we would see that that doesn't occur any time within our list because there is nothing in the list that has this text. It's only if it's spelled correctly. So that's a nice thing that we can check and count how many times something occurs within a list. Another thing that's handy is that we can look at what is the index of a value within the list. So if you say, okay, I want to know how many times does this occur and where can I find it in my list, you can use station_names.index, and then again, the thing you want to find the index value for. So in this case, we'll do Helsinki Kumpula again. And when I run this, what it's going to do is search through the station names list and return the value that is the index of this text here, Helsinki Kumpula. So it finds, yes, there is text called Helsinki Kumpula within this list, and it's at index number 2. If I was to add another cell here quickly and just print out station names, you don't necessarily have to do this. Station names with index 2, sure enough, we get Helsinki Kumpula back as we would expect. Just as the case was above, if we type in something like station names.index of Helsinki Kumpul, we're going to get a value error. In this case, I think we actually get a pretty useful error message too that says Helsinki Kumpul is not in the list. So if you go searching through and search for something that's not present in the list, you get an error message that says couldn't find anything matching that inside the list. So this is not something that searches like just for the text. So like you know, if you thought like, oh well, I'll just look for the index of Helsinki, and you might think, okay, well, all 5 stations have Helsinki in the name. It still comes back saying, nope, there's nothing in the list that matches this string, because it wants to find something that matches exactly this character string, not part of it, but the whole thing. So that's just something to think of, that, you know, if you're searching through your list to find several different things, you might need to search for each one individually. The last one that I'll show before we take a quick break here is just about reversing the list. And I mostly want to show this because there's potential for trouble here. So if we print out our station names list, we can see here Kaisaniemi, Kaivo, Puisto, Kumpula, Lighthouse, and Malmi Airfield are the stations that we have. If we then do station names dot reverse, this is probably pretty intuitive, but what it's going to do is reverse the order of the items in the list. If you run that, you'll see you don't get any output written to the screen. This should be clue number 1 that you should be careful with this, because it doesn't return the list, it returns nothing. But if we go back up to the cell above here and print our list out again, just by running that cell, you can see now that the items in the list have been reversed. So the reason I mentioned that is because there is a tendency to want to do things like, say, station names reversed, for example, and assign this station names.reverse output to another variable called station names.reversed. You can do that, no problem. But if you then go to print out station names underscore reversed, you get back output that says none. Because when this reverse operation happens, it returns nothing. And so if you're not careful and you said station names equals station names dot reverse and ran that cell, you will have then done a nice job of deleting your list. So this is mentioned here mainly as a cautionary thing, that if you want to reverse your list, that's perfectly fine, but be careful that the things like dot reverse returns a value of none. So if you try to assign that to the name of your list, you're going to delete your list in the process. And similarly, when you do list.sort, you can imagine what that does. It sorts things alphabetically. We won't play with that example, but you're welcome to do it if you'd like. But similarly, it doesn't return any output. So if you assign something using list.sort, you're going to nicely delete your list. So be careful. At this point, I think this is a good place to pause. Maybe we'll talk about the good coding practice stuff after the break, very briefly, because I don't want to take too much time with that. But are there any questions before we take a quick break?
I have a few announcements, but first the questions.
Yeah.
Please. Okay. two quick announcements. I would ask you who are using CSE notebooks to go and destroy your instance. So you can save, if you're now working on the copy of the lesson, save that, close the browser, and then go back to the CSE notebooks and click destroy button. And then relaunch the instance. So maybe do it now before the break so you'll have the instance running. There we did some updates here during the morning, so you'll get all the tools ready to go. And the second announcement, on Slack you can find the solution for downloading Jupyter notebooks on Binder when working on Chrome. So we have crowdsourced now the thing. So do follow Slack for any updates and questions and so on.
Yeah, so why don't we take 15 minutes? So come back at 10:35 and we'll continue at that point.
Excellent. Feel the vending machine
Yeah.
working. Yeah, indeed, we're just chatting with Sakke that we could have done those tests that are, and all in all, like, I guess we can do the tests without even using the nose
Yeah.
package. But I did,
Yeah.
I was just like,
Yeah, no,
trying to
that's
make-
right,
make
that's right.
things work yesterday,
Yeah.
so, yeah.
Hey.
Thanks for letting me come along.
Yeah, no, it's I'm glad you. I don't know.
Great. I love the logo.
Yeah. Okay. Oh, good. Good. Yeah. I mean, it's like this is something with I don't know. I mean, maybe it's different with like physics students, but like for a lot of the geology and geography students, I think the kind of idea of coping is seen
I'll
as
use the
like
toilet and leave that.
this sort of big step to take. So we're often like spending a lot of time thinking about how do we come up with something that people can relate to.
Can I ask, so I also use a microphone, which is post-race and stuff like that. Why, how do you do the streaming? And how do you also get that to work with the microphone that you're using, or you got
Yeah.
a microphone?
No, it's a second microphone. It's not an ideal solution, but yeah, what we're doing is we're streaming on YouTube with this software called OBS.
Okay.
It's just like a free open source software package that you can kind of configure easily. Like setting up a YouTube live stream is actually really easy.
So it's unlisted, or?
It's public, so we basically like made the decision. Yeah.
No, please, no, I'm just here to watch.
Oh, okay. So this happened to me last time as well. I just keep getting an error pretty much all the way through.
Okay.
So
So maybe
it's,
there's something that wasn't.
Like all the way.
So let's go.
Yeah.
So
Yeah, start from the beginning? Okay.
yeah.
Yeah,
Did you
okay.
run these first?
No, but
You ran those, okay. Those first 5 cells. Is there something wrong with? Okay. It's here. So we have to be careful with like this. When you use type, it should be parentheses, like the kind of this one,
oh, okay,
not the square brackets.
But I do actually say square one though somewhere.
So the square brackets are for like when you're making a Python list or when you're referring to a value like an index.
okay,
But
this
if you're using a function, you always use the
the
parentheses.
brackets. Okay, let's
So
try
let's see if you do, that
Yeah.
should, yeah, the brackets kind of get a little bit annoying because it's maybe hard also to see on the screen, but if you run that, so yeah, hold down shift and then hit enter,
okay.
yeah. So my guess is that,
But there's oh yeah.
let's go down a little further to where we make this like station names list. So keep going down. So here, so that should have worked. Printing station names is probably going to, so it doesn't look like you actually ran this
Yeah.
here.
Because there was a problem all the way through,
Okay.
so I couldn't really run.
Yeah. So that won't work yet because you have to run this cell first to, like,
How about
the text is there,
mm,
but until you run the cell, it's not
okay, so
in memory to be able to access. So like, yeah.
okay, can I ask a really silly question? So
Hmm?
this is already there, right? But
Yes.
this one is like
It is the
the
square
square one.
brackets this time, yeah. So it's like,
I really struggle.
no, it's okay.
Yeah.
So, you know, for functions, or for when you want to use something like a function like print,
Yeah.
you have something like print and then this kind of thing, and
Yeah.
right? For lists, there's basically two ways in which you're going to use the square bracket. One is to make a list, so we have like my list equals, and then it's the square brackets, and 1, 2, 3, whatever. The square bracket will be used to create this. This is the way basically to identify that what you're trying to make is
Oh yeah, I have
a list.
stupid question actually. I run all
Then
the cells, but for
also,
some
if you
reason
want
I
to find a
cannot
value in the list,
part at all. It doesn't identify the.
So where
you
do
use the square brackets to
define
indicate you want to
station
search
ID?
within that list to find,
So if you
for
run
instance,
that, so
the value at index
that
0,
hasn't
and if
run.
we
So if you try to run
printed that out, then what we should see is the number 1
Yeah.
from the list we
maybe
created here.
click on it again.
So anytime you're using a function, you'll be using these kind of
So it's
just regular parentheses.
I don't know why this
With
happens.
lists, you'll be
on its
using the
rows,
square brackets, and you
so
just have to be
change
careful
it,
that,
into a code cell.
Okay.
that you don't mix them up. So like here, yeah, what we're doing is we're making a list.
Now,
So what should I do is I run this one first and run this one later to see if this one's working right.
Yeah, so this like
so
what we've done in the exercise is we've put the text into the cell
Yeah.
so you didn't have to type it in, but until you run the cell by doing like the shift enter,
Yeah.
then it's just the text is there and it hasn't actually created the list called station names. So like yeah, once you run the cell, then this should work.
run all the cells.
Like this?
Yeah.
Okay.
And then the same thing looks like for a lot of these cases here, the issue is that we maybe just had the square brackets instead of the
Okay,
parentheses.
sweet. Because I don't know, but like from there it really looks like a.
I know, it's hard to see.
Yeah, thank you.
And it's,
yeah.
yeah.
Okay.
So you
Yeah.
just go there
Thank
and
you.
Yeah, you're welcome.
So my other question actually was going to have is like, so you have all these different like ways that students can feedback to you during the class. How do you cope with that? Like, because they could ask you questions on Slack. They could,
Yeah,
They could put stuff on YouTube comment or something. I guess. Like,
yeah, that's right. That's right. I mean, sometimes, like I'll say the YouTube chat, sometimes we miss. But otherwise,
that's new.
like the other, I mean, for this course in particular, like we've always co-taught it. So, and basically the two lecturers always come to class, and the other person is there essentially to like help out with making sure the polls are ready to go and like monitoring the Slack comments. And we have, I think, 3 course assistants as well. So we have sort of a bit of a team to keep track of things because otherwise, you're right, like it's just, to do it individually, I have seen, actually I taught once before a software carpentry group, like they used to do these boot camp things.
Yeah.
And there, they had this like Etherpad thing they used, I don't know if you've ever,
I've also not heard of Etherpad.
okay. But basically it's like a, I don't know, it's kind of like a live chat that anyone can type to without having to log in or anything, so like people can just type in questions or whatever there. They always had that open like in some part of the screen so that the instructor could see the questions as they were coming. I guess we try to just maximize the screen real estate and keep the lesson visible.
Yeah, it's really good because what I've done in the past, I think I've got so many good ideas from watching you do. Like when I've been teaching, I've had like I've had one of these Prisma poll classes
Yeah.
on a screen only I can see. So like it's not up there like people watch it. It's just like so I can if I'm talking about something and something bubbles up on there, I can answer it without them having to ask questions.
Yeah.
But that was with a really big audience, like
Yeah.
much bigger than this.
Okay.
I was like this master's program orientation classes.
Okay.
So like it's first years there. They want that. There's a big power gap and stuff.
Yeah.
So
Yeah.
that's great.
Yeah, so I did like, I kind of supported a version of the same course that was taught in Turku this spring, and like for that I was doing like it's kind of live question and answer sessions once a week with the students, and then I had 2 screens, and like it was a similar setup, but like basically I had the Slack and the YouTube chat open on one separate screen, so like they could see my screen, but I could also see when they were asking questions. We haven't yet figured out like how to get this screen doesn't seem to work anymore. It used to. So we'd like to have a second screen where we can have the OBS controls and things like that not open on the same screen that people can see. But
So I have a couple more questions if there's time. So
yeah, that's fine.
So did you choose like this screen on purpose for this presentation?
Yeah, I mean it's partially based on size, number of students puts us in like a room like this. But yeah, we wanted something like this. I think there's actually like a decent number of power plugins options too, so that's also something that we kind of said, you know, we need a room of certain size and it needs to have power, it needs to have projector. I think it does, like, this has like the Unitube system all set up, so if you want to do that, you can, but we kind of do our own.
I was going to ask why you use this over Unitube, because
Yeah, I think it's just a bit easier to configure, like, I mean, I guess they could easily, I mean, with Unitube you can certainly have it like recording what's on the screen, but to put like the little, I mean, we do have a little picture of like the teachers, like there's a webcam here that looks down, and so, you know, then that's I think harder to do with Unitube.
Last question, so did you develop the materials yourself for this?
Yeah, I mean, this is maybe the 4th or 5th year that we've taught this course, and it's been partially stuff that we've been developing, like, and partially inspired by like the software carpentry group. I don't know if you know.
I do. I know people who are involved in software carpentry.
Yeah. Okay. So like, I mean, for me, I took a software carpentry boot camp back in like 2010 or 2009, and I really liked the kind of format and things, and then that sort of inspired what this course has developed. So when we started looking at their lesson materials, they go a little bit different direction than we do, so we kind of branched off. But like at the start of all the lessons, you can see like we have a reference to software carpentry as like kind of inspiration.
Well, thank you very much for letting me come along.
Yeah, it's a pleasure, really.
I'm going to stay probably until about 11 or so, and I'll sneak out.
Yeah, it's just whenever you want. I was going to say like that, there's no need to stay. But I thought this might be an interesting format for the course to see, like, compared to a normal lecture. So I think I'm a fan of catering the sort of teaching styles for these different types of courses. And like for this course, I think that like having people sit there and type stuff in real time is much better than like having them try to, I don't know, sit in a lecture and
Oh, this is really great. I really enjoyed it.
Oh, good.
Goals of ideas and thoughts and inspiration. So.
Dave, no.
That's great.
So thank you both of you to like
How do you make the @ sign on a MacBook?
Okay. Sorry. Okay. All right. So it's this option.
Yeah, we just
no.
No.
Sorry, it's Shift.
Shift. Okay. Yeah, and it's logical. Yeah, we just discussed this that then you press some Control Q and quit everything.
Yeah. No, that's right.
Yeah, I opened the private browsing window with my own stuff on it, so I won't get confused in the midwhile.
Okay. Yeah, I think. Okay, well, just let me know if there's things that you need me to do. I can try to like. Is there anything you anticipate, like polls or anything like that, that I would need to tinker with?
No polls, no nothing. Maybe if you can then jump in with exercise 2 explanations, because I might be then like after talking for 1 hour then a bit, and also a bit monitor the time. So I think I'll take an hour with the.
Okay. So
Git
I
stuff.
think I have. I mean, I don't know if you looked through the good coding practices.
I did. Excellent.
Stuff.
Yeah.
There's a lot there, and I feel like maybe I can just very quickly just mention.
Yeah, and
that
then they
without
can
having
read
to
up.
Spend much time.
Sure.
Going in detail. But just to kind of make the point that like there's different ways in which you can include comments, and that comments are important. I like the idea of that kind of being the comeback to the lesson part, but like in terms of like that's the way that we transition back to being on the break.
And that's it, because now we start then by cloning exercise 2, so now it is as it is, and we can then check up. In the meanwhile, Johannes fixed everything.
Okay, that's awesome.
Some people were already working on the exercise.
Okay.
That's the thing.
All right. Yeah, that's very good. So then,
Oh yeah, can you reset the mouse scrolling direction?
yes.
That's
Yeah.
also one source of confusion.
I can do that. Yeah, unfortunately, it's stupid, so it switches my trackpad too. Even though it's under the mouse configuration, it switches the trackpad, so that's why I turned it off.
Yeah.
Um,
So I'll leave my computer here if you want to mess around in Slack. And
let's
maybe
see.
because there was somebody said on Slack with the audio, so maybe good to check that.
Audio is pretty quiet. I guess we can turn this back on. And I think we're ready to go back. No. Mhm. Okay, folks, let's continue here. So we're kind of done with our Python lesson today, at least in terms of the kind of hands-on typing stuff in. We're going to talk about Git for the second part of the lesson today, and it's good to spend a bit of time on that, and you may also be typing some things in and testing some things out there. But the learning the Python kind of hands-on stuff is mostly finished for today. But we haven't done our good coding practice of the day yet, and so I'm just going to go here quickly to the course website for this, and there is a page here about good coding practices related to describing your code. And here you can find some information about adding comments and using these markdown cells in Jupyter notebooks to help describe a bit more about what your code does. So there's a number of reasons why you might want to do this. I'm just going to briefly highlight a few of those, and then I would invite you to read through this in a little bit more detail when you have a moment. But to deal with the first question here about do you need to describe your code? Well, the answer is absolutely yes, especially at this stage. When you're getting started with programming, it's really essential to be adding in some text to describe what you're doing. Sometimes it's for yourself. A lot of times it's for us so that we can see what you're doing, because sometimes there's different paths to get to the same solution. I've provided 4 reasons here about why adding some additional description to your code, so this is text that doesn't relate directly to the code that's being run, is a useful thing to do. So first off, these code descriptions make it easier to understand your code. This is perhaps somewhat obvious, but by adding some text describing what your code does, you can explain a little bit more clearly how something works, and that's an essential thing for usability of the code in general. We want you to be writing code that people can understand, and sometimes people need to read a sentence or two of an additional description to understand what some part of the code does or why you've chosen to do something a certain way. It also makes it easier for other users to use your code, because once you've added a little bit of extra documentation there, then you can pass off the code to somebody else, and as they're reading through it, they don't necessarily need to read all of the functions that you're using, but they can read the description of what the code says and understand it that way. It's also a pretty useful way to help in debugging your code, especially when you're learning to program. There will be times where you're like, okay, my code should work, but it doesn't work, and I've typed in this stuff, and I don't know why my code doesn't work. Just by writing down the description of what you think your code does line by line, sometimes you'll find that the description you're typing in doesn't match what the code itself is actually doing, and in that way you can find problems. So if you think you have the code that should be filling some list and printing out the values, and you start typing in that description, then you look at the code that you've written, you may find the two things don't agree, and this is a useful way to help find problems in your code. And the last one here is that these code descriptions are a big part of why Jupyter notebooks are so powerful, so useful, because we have one common document where you can include nice descriptions of what you're doing right along with the code that does things like some kind of data analysis, produces some plots, whatever. These text pieces that you have in there could be a sentence or two, or you could write like the introduction and background sections of some scientific journal article in a Jupyter notebook, and then when you get down to the methods and results sections, you could have the code there inside the document to do your kind of analysis, produce your visualizations, your results. And then if someone says, okay, I want to know how you how you did this, you can hand them the entire document that has a full description of what you've done and all of the steps there in a single place. And as far as open science goes, that's a pretty cool thing to be able to do, because you say, okay, you want to reproduce my results? Here's my Jupyter notebook. Have at it. So I'll also say here that the internet says you shouldn't comment your code. If you go Googling around looking for like code comments and best practices of code comments, you'll find a bunch of people that are saying like, oh, you shouldn't need to comment your code. People don't understand what you're doing, then you've written bad code. Okay, those people exist, but when you're a new programmer, you need to comment your code. And if you're a professional and you're experienced, you've been writing code for 20 years and you write beautiful code, no problem, I would still say that it wouldn't hurt to put some comments in there, because you never know whether someone who's been coding for 3 weeks is going to look at your code and I have no idea what this is supposed to do.
Or you yourself, after 6 months, are looking at your own code and you're like, what is this doing? I'll just rewrite the whole thing, because that takes less time. So,
yeah. So, this idea in some sense does make sense, that you should be trying to write code that is easy enough to understand that someone can look at the code itself and see what you're doing. But that won't always be the case. And especially when you're getting used to it, as Volko says, there will be times where you just want to have the explanation from yourself to yourself of what the code is doing. So about the comments, there's a couple different options here. There are that are described. There's line comments in Python. So if you want to comment for a single line, you start with this number sign or pound sign or hashtag or whatever you want to call this thing. This will indicate a comment, and everything that's to the right of it will be ignored. So I've put it in here in one of these cells in a Jupyter notebook, and nothing happens in this cell. When it's run, it just gets skipped over. And you can use this, for instance, to say you've got some list here, and you say this is a list that has names of FMI observation stations in Helsinki. And then you've got the name of the list underneath that. That would be a pretty common instance of what we'll ask you to do, is to include these line comments to describe kind of line by line what your code does. You can also add them after some operation, or you can have like some part of the code that doesn't work, and you just add a line comment to skip over that line because you don't know why it doesn't work, or it used to work, or you say, well, this is broken, whatever. There are also block comments, and those are going to start with the triple quotation marks. These are basically the same thing as line comments, but they can extend over multiple lines. So these are inside the code. You put a triple quotation marks, type some stuff in, and then you end with another triple quotation marks. And this basically will just ignore everything within those quotation marks. So you can add maybe a little bit more information, like the list below contains names of observation stations in Helsinki. More information and a complete list of stations can be found at some website. So if you want to add a little bit more info within the code, you can do that. If you want to add something like, if you're using this code, make sure you cite my master's thesis. You can add those kind of things in there as well. And you can, of course, use that to comment out blocks of code as well. So finally, about the Markdown text, we've already started using that a little bit, and you'll continue with Markdown after this, and get some practice even in this week's exercise about Markdown. But this is the real power of the Jupyter notebooks, is the fact that you can have now in here these cells where you have not only just a single line or little description, but you can have something like a Markdown cell here with a data source, and then some information about what kind of data you have present, a link to a website, some text in bold. So you get a lot more formatting options here, that if you really want to describe things in more detail, including nice lists or code blocks themselves, you could even have embedded within your Markdown. You can do that, and then you can put a normal code cell beneath that. The point for this is that we'd like you to be using code comments. We'd like you to be using the Markdown cells to describe what you're doing in the exercises. Sorry, I felt that coming. So with these kind of things, the main point is that the code you write is something that we'll do an assessment on. We'll check to see whether you got the right solutions in the exercises, and we'll grade things that way. But we're also going to be looking for code comments, and there will often also be points related to whether or not you've added comments to the code to help make it easier for you to read and easier for us to understand. So you should think about it. One part of generating code or working on the exercises is to write the code itself, but an equally important part is to describe what you've done with some regular language comments, preferably in English, but just to make it easier for the graders. But you can comment, if you're writing comments to yourself, of course, you're welcome to write in whatever language you prefer.
The internet said that if you're 120% sure that nobody else is reading your code ever, then use whatever language. But if somebody else will read your code, and during this course at least the assistants as teachers are reading, so do everything in English.
Yeah. So any questions about code comments, code descriptions, things of that nature? Looks like no. Okay, so we're going to switch gears here. I'm trade places. I think Volko's going to take over. I think we should switch microphones because that one doesn't seem very loud.
This should be you.
Yep.
Okay. Yeah, this is a bit louder. Okay, so we'll move forwards to learning about version control, and I think this discussion about commenting your code is a nice transition to there. So in this course we teach you how to program in Python, how to automate data analysis processes, how to plot things, but we also aim at teaching you these good programming practices, especially related to open science, and then version control, and then sharing your results on GitHub is one way of doing that. So we'll do some hands-on stuff. Feel free to follow or do along as I do, and then please stop me if I'm too fast. Ask Dave, Lotta, Sakke is also here if you have questions about that. So we are continuing in the lesson from Introduction to Version Control and GitHub section. So first, a bit of motivation and definitions. So some of you have coded before, some of you haven't coded. Maybe first a raise of hands, who has used a version control system before? We don't have a poll for this, but yeah. So most of us haven't used a version control system before, but I bet something like this that we see in this PhD comics situation might be familiar. So you have done at least some weekly course exercise, or maybe a bachelor's thesis, master's thesis, and then you're like, yay, final document. And then you're like, no, then you print the PDF, and no, there's million typos, and then you do final underscore OK. And then you send that to your supervisor, and then you even notice that, I miscited something, or I misspelled my name, and then you have final revision 8, final, OK document. And then you send it, and then eventually you notice that no, you send an email to your supervisor that no, please ignore the latest version, take the final 2.7 that I sent yesterday. So then that's also kind of a way to control your versions, but maybe not such an efficient one. Another example could be that you have the files on your own computer, and then you might put some timestamps, for example, in the file name, or you might have some folders with like 2018 files, 2019 files, and you maybe back up some versions and you do it for yourself. That's also kind of good approach, but that's also error prone. You might overwrite some files that you didn't want to, or you don't remember to do it. And then if you need to collaborate with somebody else, then you have everything on your own computer. And here I'm just talking, for example, referring to a text document, but it's the same thing if you have images, text, programming code, so whatever you develop over time, so you can somehow control the versions and if needed, go back in time to a previous version that was working nicely. So that's kind of the core idea of version control, and then version control systems such as Git are pieces of software that then handle parts of this process for us. Yep. But still, like even with GIS software, you do some output 1, 1, x, final, okay. So I still do that sometimes, but I now with programming code mainly use Git quite successfully. So indeed, what is version control? So you have some baseline document or a folder of documents. You can start from scratch by initiating a new one, or continue working with existing documents and start tracking changes to those. Then if you add one line of code or one line of text, you commit or take a snapshot of your changes, then the version control system records those changes as then the next version. And then you add more changes and then take a snapshot, and then those are stored, and if needed you could go back to one of these previous snapshots of your document or the whole project. So version control system tracks changes to your file or files over time to keep things organized and to allow you to go back in time. Just check it. Yeah, and indeed also then you can, if needed, you can compare what changes have occurred between two time steps, and especially when collaborating with projects, that can be very useful thing to do. So then, just to summarize, why are we teaching you to use version control systems is to avoid these situations such as with submitting your file via email. So we imagine if all of you would be emailing the submissions to us, and then you would be like, hey, here's exercise 1, and then, oh no, here's exercise 1, edit 1, and then no, take the first. So then it would be quite a hassle for us to manage all of your versions, all of the submissions and such. So in order to work systematically and avoid kind of parallel versions that are then not tracked and synced, so that's why we want to use version control here. And there's different version control systems out there. Here we'll be using Git, which I guess is the most popular one when coding. Of course, if you're using Microsoft Office, I think there's some sort of a version control system behind there. What's special with Git, won't go into too many details, but it's kind of a distributed version control system. So I can work on my files on my computer, I have the full history there, and then I can have a separate kind of instance or a copy of my project on GitHub or on another computer with the full history. I can work on those two places and then synchronize those changes. So that what it basically means, that Git is a distributed version control system in kind of as opposed to a centralized one where you have one server which has all the changes and then you only update that one. So indeed, Git is one of these version control systems developed by Linus Torvalds, who studied here, I suppose, back in the day. And Git indeed takes snapshots of our project locally and on GitHub, and we can use certain commands to do this workflow. Great. All right. And then all of you should by now have at least had a glimpse of GitHub. So we'll discuss a bit about what is GitHub eventually all about. So basically it's a place to host Git repositories. So we have the name Git and the hub, So it's on the web. So essentially it's for that you can dump your projects to GitHub and then open it, fetch it to another computer. But beyond that, it's also a social network, so you can follow other people's updates, you can share your code, you can collaborate on projects, and so on. So ideally, for example, if we would publish a scientific article in our research group, we would have a linked GitHub or GitLab page where you have maybe some data description and then the analysis codes we have used for producing the plots, and then if somebody asks how did you do this, then we can refer to that GitHub repository, and you can take that code and start developing that further. So essentially GitHub is one of these places where you can actually do open science in practice. You can release open source code, use other people's code, and so on. So we'll touch a bit upon that. Mainly you'll be working during this course on your own exercise repositories. I'm kind of dreaming of having some group work exercises in the second period, so then you would be really kind of leveraging the collaborative part of Git and GitHub. Yes. Yeah, and then one nice thing with GitHub is that you can then, because there's always problems with software programming code. Our web pages might have some issues. So of course here you can just come and tell us that link is broken. But then you can also, if a project is on GitHub, there's a little tool that you can go and say that, hey, I'm using this package, but on Windows computer I get this and this error. Most often if you go and, hey, I'll raise this issue, then somebody else has already done that, and you can follow the discussion related to how the project is developing. So it also makes the development of software and scientific code or analysis processes more transparent. During this course, the repositories, so your own personal exercise copies, are private, but you have full administrative rights there, so if you want, you can put them as public. Maybe don't do that for the weekly exercises, not to spoil the joy for others to solve the problems, but yeah, maybe that's that. Yeah, and we'll now start working in practice. There's kind of a lot of this Git vocabulary out there. You'll get more familiar with it once we proceed. So maybe that's enough of that. And of course the internet, YouTube is full of tutorials. Here we try to go through those steps that you need to work on the exercises of this course efficiently, and then hopefully you adopt Git into your own workflow, and then you learn more. So maybe the best way to learn is to actually run into some trouble, and then when you try to solve the problems you ended up with, then you learn to use Git more efficiently. But hopefully during this course, if you follow the kind of workflow we have planned, when working with the exercises, it's quite unlikely that you'll end up in big trouble. So I'm moving forward to this Meet Git page, and we'll actually already now start working with the exercise 2 at this point. So if you haven't done so, some of you have done so already, but just go and accept the GitHub Classroom assignment. So we'll have something to work on with this tutorial. I think I did that already. So you can go ahead and do that. While you're doing this, we could stop for a second or a few seconds to look a bit closer at the components of this space or the exercise repository. So repository is one of these kind of Git words. Repository in Finnish, repo. So in Finnish it means basically a place to store your files. So säilytyspaikka, repository. I think that makes it easier. So it's just, it's often a folder if you have it on your own computer. On GitHub it's this exercise repository, for example, which has a file structure and then all the files we are working with. So once you clone the exercise, you'll see the front page. So it's this readme file, readme.md. So it's a markdown file that you can edit using the markdown syntax. Then there is the notebook file, and then there is kind of this little hidden file related to Git. We'll come back to that in a second. And on GitHub you can view these files. Sometimes, well, yeah, sometimes the notebooks don't render nicely, but often they do. And then you can also edit things on GitHub directly. Editing the notebooks is a bit difficult on GitHub, but if you want, you can just go and edit the README. I could, for example, I'll just do this quickly, you don't have to repeat if you don't like to. I could add a new header called notes, and then it says commit changes. So I'm committing the changes, I'm taking a snapshot of my project there, added a section for notes, and then I commit the changes and they are directly on GitHub. Yeah. I guess everybody who wants to follow now has the exercise folder ready. So let's continue with the lesson. In addition to your personal copy of the exercise 2, you'll need a Jupyter Lab instance. If you didn't do so, well, you don't need to destroy it now if you already have it open, but do restart it before actually working on the exercise. We'll then, at the end of the lesson, discuss what is the exercise actually about. Now we will just kind of somehow magically from GitHub get the folder on the computer without actually having to download and upload files. Assuming that you're working in the CSC notebooks, you should have these two folders there, exercises and notebooks. If you're working on your own computer, I recommend that you now create a folder somewhere, for example, documents, under the documents directory, called exercises or Geo-Python exercises, where you will then collect all the exercises of this course. So you need to be a bit organized yourself first. If you click on the exercises folder, you see that it's empty, and our task would be to actually get the exercise 2 personal repository here by using Git. And that's what we'll do using a few easy steps. Overall, how we work with Git during the lessons here, just a second, is that we start by indeed cloning. We have the kind of exercise template on GitHub. You create your own personal copy using GitHub Classroom, then you kind of clone it, create a copy on the cloud computer or your own computer. Then you work on the exercise, do changes, take snapshots of the project while it proceeds, and then finally you push the changes back to GitHub. So that's kind of the thing we'll be repeating each week. And we'll now go through those steps here. Pretty much after this session, you should be familiar with at least these 6 commands you'll be using quite regularly. There's a bunch of Git commands out there. There's a link to this Git cheat sheet, and actually we have a pile of copies in here, so if you prefer a manual copy, maybe Dave can pass them around. There's maybe not one for, yeah, so we have those then there. So you see it's already 2 pages of A4 of the basic Git commands. So here we'll go through these 6 very basic commands that you need to actually to get your exercise, work on the exercise, commit your changes, and push your changes back to GitHub. Okay, still a few more kind of definitions and concepts before we get hands-on. I hope this figure helps you to get the kind of idea of the whole workflow. So, okay, we defined repository, so it's kind of the place to store your files. Often it's just a folder on your computer. We can also call it a folder. Collection of files. And kind of when everything is nice and clean, you have a repository with snapshots of the changes. So for example, solved problem 1, solved problem 2, solved problem 3. So those are the snapshots in your repository. The latest snapshot is kind of the current state of the work. And if you notice that, no, I did something super wrong in the latest commit, you could then set the state of the repository to match with that commit from last week. But of course, at least me, I often have a very, very messy work table. So you test something, you do things, and you have 3 files open at the same time. You're working on problem 1, problem 2, problem 3, readme, and then some other test files. So how we work with Git is that we have the working directory where we start working, we test things, you might delete stuff and so on. And then finally we take the snapshot, so we commit the changes, but in a way that we can then, for example, if I would have 3 different files with problem 1, problem 2, problem 3, I maybe did some edits to all of them, but I only want to commit problem 1 as one clear snapshot of my exercise repository. So then I would add the file with problem 1 solutions to the so-called staging area. That's a bit difficult word, but that's kind of, you queue up or you put into the index the changes that you actually want to include in the next snapshot, so in the next commit. So I could, for example, do git add problem 1 and then git commit, and when you commit, you actually take the snapshot, you give an informative commit message. So for example, solved problem 1 or added a function about x and y. And then I could go back to my messy table, continue with problem 2 and 3 at the same time, and then I need to go home. And at that point, I'm quite happy with problem 2, and then I would, or at least part of it, so then I would add problem 2, commit. I could even add problem 3 and then like improved it a bit, for example. So the staging area is kind of there for you not to dump all your messy desktop into the nice clean snapshot of your project. So you can have stuff on the desktop that you never commit to this kind of snapshot or the kind of permanent snapshot repository. So there's you might have some files in the folder on your computer that you don't want to push, for example, to GitHub. You might have some passwords. Well, maybe you shouldn't store your passwords in there, but some tokens and whatever. But this will become more clear. There is a way to kind of bypass the staging area and kind of commit everything, but we will instruct you to always tell Git which file you want to add, because you need to be in control of what you're doing. If you're 100% sure that you know what you're doing, you can then add everything or commit everything. But always, at least when starting to do this, always tell which file you want to commit. Okay. But I hope this image maybe helps you later on to understand the different stages. But that all now happened just on my computer or on the cloud computer. Nothing happened yet between, or it could be on GitHub, but in one kind of on the local repository, for example, you work like this. You have then committed maybe 3 changes, but then we need to also communicate over the network. So now I'm happy with my project in here, or then I just need to go home and maybe push backup stuff on GitHub. So then we synchronize the different repositories, which can have their separate. They can be at different stages. So then it's always good to first, if you're working on your own computer or the cloud computer, so first pull changes to check. Often you are up to date, but pull changes from the remote, and then you will push changes to the remote. So this Git push then sends all the commits to the remote repository. And of course, in this image, we don't have it, but if you are kind of starting from the scratch on your local computer, you need to first clone the repository or then initiate an empty one. Yeah, so here you'll be mainly working with yourself in a way, but let's say that I would go into your repository, make some changes on GitHub, and if you would try to push things to GitHub in the meanwhile, while I went there and changed something, then you might run into some merge conflicts. But yeah, let's see if we'll get those during this lesson. Okay, finally, let's start working. So using Git from the command line, I know not all of you are super familiar with working on the terminal or the command prompt. Yeah, no, maybe. You'll need to know a couple of command line commands. So I'll just show them here. If you want to study more about basic command line commands, there's a link here, but you'll learn the basics just by doing. Okay. On CSC notebooks, the thing looks like this. Maybe Dave, now I need your help to zoom in a bit, or is it just from here? Yeah, I figured it out. Is that enough? That's maybe too big. Oh, sorry about that. Yeah, so you can open the terminal window. And the point here is that I am located somewhere on the drive. So currently it shows the username and then the folder that I'm located in. And you can, for example, type ls, which is a command line command in the Linux terminal to list files that you have in that folder. So this terminal window is now located kind of at the default root folder of the CSC notebooks instance. So we have folder exercises, notebooks, and then I have some random untitled notebook file there. You might not have it, but our first task was to actually go into the exercise folder. So we could start by that. So if you do something in the file browser here, it's not related to what happens in the terminal. So there's this other basic command called cd. So change directory. And if you are like me and have trouble typing in exercises, you can press the tabulator and then it kind of automatically fills the file name starting by E if such exists. Just make sure that I follow the script, which I didn't. Yeah. So if you fall behind, there's Sakke, Lotta, and Dave helping out, and ask your friend as well. Yep. Okay, now we're ready to go. So I am in the folder where I want to start collecting my exercises, and I have my GitHub repository on GitHub. So now I should somehow get that GitHub repository in here. And for that, we will use Git. So we'll start by using Git from the command line, and at the end of the lesson, you might have noticed that we have this nice little Git plugin here as well. We'll learn how to use that. Emil has a question there. No. Oh, yeah, sure. But first, we need to understand how things work on the command line in order to do the plugin tricks. Okay, is it okay to continue? Yeah. you might just hit Git and enter, which will give you some type of help or documentation of some types of commands. And especially if you're working on your own computer, you might want to check which Git version is installed on your machine. I read from somewhere that anything above version 2 is just fine. And if you're working on the cloud computers, Git is installed. If you're working on Windows, install Git for Windows, then at that stage. Okay, and then before we, again, actually get going on with the repository, we need to do a bit of configuration for Git. I'll just show quickly from here. So at least we should tell Git who we are, because when we are making changes to the repository, the changes get metadata about who did the commit, so you get the credit for the work you did, and also you're responsible for the changes you made. So if you mess up something, then your collaborators will know who did those changes. So we'll start by running these codes. You can also check from the course web pages and copy paste things. There's not too much to type in, but some. So we will configure our username and then we'll do something more with the credentials so that we can actually then start doing the changes. Okay, so git config global username. So the global means that then this will apply to all of your Git repositories on that machine. And if you're working on the CSC notebooks, I think you shouldn't be able to do this every time, hopefully. Oops. So put your real name, and then I should find the delete button. I don't. Okay. That's there, and then there was this other configuration command for the email. If we wouldn't be doing this now, Git would prompt us for this information later. So Git is quite an informative piece of software. It always tells us what to do. And if you're wondering how to copy paste things on this terminal window, you can click Shift. How was it? Shift and then second mouse click, and you get this paste, or then I think you can also click the second mouse click directly. Okido. That's there. And if you're unsure if you actually did it or not, you can then call git config username, and it should print your name on the screen. You can check it if you want. But this information then will be attached to all the commits you make, and if you push them to GitHub, then also it will go there. So part of the version control, especially when collaborating, is to know who did what and when. So now we told the who part. Okay, then there's another line which we need when we'll use the Git plugin. You can go ahead and copy paste this from the course page. So what this does is actually, like, Git will prompt us for our GitHub username and password when we communicate over the network. So this command will kind of temporarily store that information so that we don't have to type it in all the time. And there's this timeout parameter. It's in seconds, so if you want, you can increase that one as well. Sakke, how we're doing? Can we continue? Yeah. Yeah. Okay. Okay. So then, to get started, we need to clone our repository. I actually jumped ahead, and we are already in the correct folder, but indeed cd folder name, you can move between directories, and cd ... you can go up one level. Now we need to go back to GitHub in here to your personal exercise repository front page, and you'll find this clone and download button which tells you that you can clone this repository using this URL. So again, let's copy that in order to clone the repository. So cloning kind of creates a copy and synchronizes your local copy of the remote repository. So they are kind of automatically then synced. So I would go in, I have copied my link from the GitHub repository page from here. I should have it on there, and then I will go git clone my repository cloning address. And this is the point when you can test if you remember your GitHub credentials again. Should be correct. There we go. And then once you have cloned successfully, you can see in the file browser, or you can then list files in that directory, and you should find the template for the exercise 2 in there. It's not that difficult. All good?
I think we should go
Yeah? Cloning again. Yeah. Okay. Yeah. So indeed, cloning, for that, you need an address for your GitHub repository, which you find from your personal. I'm now on a web browser in GitHub in our exercise organization under my personal GitHub repository. Clone and download, copy that link, yeah, and then you would type in git clone. I actually don't know what happens if I do it again. We can test, maybe I won't run it, but you would type in git clone URL, so git clone, paste your own address. Who's with me? Some, yeah. You can paste in here in different ways. Most likely you can at least press Shift and then right-click mouse and paste. On this Mac, I can at least do Command V, so you should be able to do Control V on a Windows computer. Yeah, so then once you run git clone, it will start printing out information, and it will stop when it prompts you for username for github.com. So this is exactly the same username you created last week, probably. So you give your username, you hit enter, then Git will prompt you for password. It won't show it on the screen because it's a password. You just type in your password, hit enter. If you typed your password correctly, you should get something like this. If you typed in the wrong password, you'll get an error, and then you can always rerun previous commands by pressing the arrow up. So you don't have to type everything again, and hit enter again and try again. Who have managed to clone the repositories? Have? Yeah, maybe. And if you're sitting next to somebody who didn't, maybe you can check out a bit and help. Yeah, I think password is the most difficult part of this step.
Should we have the same amount of objects as you, or fewer, because it's like a student version?
Yeah, I might have already done some edits there, and yeah, so don't worry about that. Yeah. Those who, yeah.
If we put our password in incorrectly, how do we then go back and do it again?
Yeah, so if you misspelled your password and received an error, you can then press the arrow up key until so you can kind of scroll these commands. I think I have it in here. No, sorry. Well. Then you either type in again Git Clone URL, or then you should be able to run the thing again. Do you have a question in the front? Or just a practical one?
I simply refresh all the stuff, so...
Just a second.
Then you can check if you actually managed to things more. So maybe you can...
Yeah, don't worry, this will be the very first thing you do in the exercises, so maybe we could proceed in a bit. What's the status kind of overall? Who have cloned their repositories? Okay, most of us. So here it doesn't matter. I could just close this terminal window and it wouldn't revert anything. So I can go again to my exercise folder, CD exercises. I press the tabulator. In the exercise folder, I have then the exercise 2 repository. And those of you who are already at this stage, you can check from the file browser that you have exercise 2 folder under the exercises folder, and then you should kind of CD into that folder also on the terminal. So CD, I start typing E, press the tabulator. So you should be at this kind of a situation after cloning the repository. If there's still somebody who needs help with cloning, Lotta is there, Dave is there. Maybe we'll continue now with those who are following, and then you can do this at your own pace during the exercises. One thing you can do now that we have those files on the cloud computer, there's a different kind of listing command called ls, or a parameter for the listing command lsa. So the a parameter lists also all the hidden files. So now you can actually see that we have this .git. It's actually a hidden folder. So this tells us that we are in a Git repository and Git is tracking the changes that is happening in this folder or in this repository. And then we can go ahead and ask Git what's up, yeah, or the status.
What actually tells you that Git is tracking the changes? Is it
It's the blue .git. So there is a little hidden folder Git. If you remove it, you lose the version control stuff. And sometimes you might want to do that if you kind of want to forget the past, but yeah. There was another question.
Yeah, I was just wondering if it doesn't show that Git, even though I've understood it.
So you did LSA. Are you inside your exercise folder or are you in the exercises?
I'm in exercises.
So you need to first go cd exercises. So if I go here cd ... I'm now in the exercises folder and I run LSA. I don't see the Git, but I need to go cd exercises to Vuokko and inside there LSA. So now we continue working inside the folder that we cloned, right? And finally you can do Git Status. Status. To ask Git, where are we at? What is the status of my repository? Git tells us that we are on branch master. Your branch is up to date with origin master, nothing to commit, working tree clean. So during this course we won't be talking too much about branches, but so that you know that Git, you could kind of have these different branches of the same project and you could commit stuff between different branches. We are now working always on the master branch, and then this origin master refers to your remote GitHub repository. So Git tells us that our local repository and the remote repository, they are synced. There's nothing to commit here, and we can just start working and committing changes. Yep. Okey-doke. So then, just skip from here. So we have cloned, most of us have cloned the repository. You have asked maybe the status, and indeed you should be inside your own personal exercise folder on the terminal. So cd exercise to your name. Question? No. cd stands for change directory, so cd folder name. So if you want to go backwards here, then you put cd ... So you move one level up. Now I'm in exercises, then I go cd exercises to Vuokko. Now I'm in my own exercise repository. So cd ... or cd folder name. Yep. Okay. Then we still have time to make some changes. So now you remember the image with the 3 boxes. We are now kind of, when we start making changes, we are on the working directory, the messy desktop in a way. So you can then open. Let's do the changes in the README file now because it's a bit more clear, and then we'll start modifying the Jupyter notebook. So in here, you can just go in the file browser, open the README file, and once you do this, you can reorder your windows if you want, so that you see the terminal at the same time and that you see the README file at the same time. And you remember a while ago I went to GitHub and added this notes section there, right? So I could go ahead then and add some notes that teach more about command line commands. I don't know. something like this. So now I have changed one line in the README file, and then I probably also want to save it. So you can do Control S or then File Save. And once I did that, I'll go again to Git and ask, hey, what's up? So Git Status, yes. And now I have just went in, added something on the README file, saved my changes, and then Git knows that there are some modified files, or there are some changes that have not been staged for commit. So we are still on the kind of lowermost level in this 3-step committing pipeline. So Git knows that we have modified README, and then Git even tells us to use git add file name to update what will be committed. Okay? So let's do that. Git add readme.md. Again, I ask git status. Now Git knows that there are changes to be committed, so we are now on the staging area with this readme.md file. Right? And then Git tells me to use git reset head file to unstage. So I could erase the changes using this command. You can try it yourself. We won't do it now. But otherwise, we have now kind of prepared the changes we made for the next commit, the next snapshot, right? So then, now we have done just a very, very simple change, but for the sake of going through the whole pipeline, let's commit those changes. So you could add more changes if you want. Maybe I'll just do that. Other note. Then command save your files. Then I have git status. Then it remembers the previous changes that I have already staged, and then it detects new changes. So I could only commit the first change, but I want to now add git add readme.md. Those both changes in there. Git status. And then finally, how do we take the snapshot? We use the git commit command with a very descriptive message. So then you type in git commit message and then the little hyphens, added notes. So you could write added notes, solve problem 1, improve problem 1, fixed typos, whatever, but do actually leave and not like blah 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 1, because then that won't tell you what actually happened. There we go. And then again, git status. So as you notice, this git status command is it's the most used git command, at least in my pipeline. So always ask git, where are we at? What should I do? Am I up to date? Because I don't remember. That's the job of git to track the changes. So now Git tells me that I'm on branch master. Branch is ahead of origin master. So origin master is again GitHub by 1 commit. So I have committed 1 snapshot of my project here on the cloud computer, which is 1 step ahead of the state of the repository on GitHub. So, and I could continue working in here and then finally synchronize my changes. I'll show the rest of the pipeline and then maybe we can see if there's some questions. So we are now here that we have added, committed changes, and then Git knows that compared to the last checkup with the remote repository, we are ahead by 1 commit. So now it's time to move to this network connection. Yeah, we'll go maybe 5 minutes over time again. Yeah, sorry about that. So first, we will run Git Pull just to check that nothing has changed. So let's pretend that Dave would have gone into my repository and changed something, then I would get those updates here. That's not the case, so then I can run Git Push. And then Git tells me in a bit more verbose way that it has sent my changes to GitHub, and I can actually go to my repository, refresh it maybe, and then I'll see those 2 notes I made also on GitHub. Question?
What's actually the difference between commits and the push?
Yeah, so commit happens in your, if you're on the local computer, local repository, so the commit happens locally, and then you have kind of the fresh state of the repository locally. Then when you push the commits to the remote repository. So you don't actually make any changes, you just kind of synchronize the changes. Yeah.
The local repository is also kind of like a backup already.
It's a parallel version, yeah. Yeah, you can look at it as a backup, because now I could just delete everything from here. I have everything on GitHub like that. Yeah, so I know most of you are doing this for the first time. There's many steps, but this is basically the whole workflow. We clone the repository, we do changes, we add and commit the changes, we pull to check for updates in the remote, and then we push to synchronize our changes. And that's how you will submit your exercises from now on. I'll quickly show, just to get it recorded, how to use the Git plugin, and then you'll have the whole exercise to practice the pipeline many times, so don't worry about it. There is the Git plugin that now recognizes that I am in a Git repository. I could add an additional note, save the file. In a bit, I think this tool should notice that I have changed something. Hopefully. Let's make some more changes. Things. And then it's a demo effect. Let's see. Yeah. Okay, it takes a few moments, but this tool does exactly the same thing. So if we can also run Git status here. And instead of running this git add, I can just git add from here. Then we're on the staging area. I can input a message, added comments, check mark. And I git commit message by pressing this button, right? And then you can check there's a history. I added notes before, I added comments, and then finally I can pull for changes, Git pull, and then I can Git push. So you can choose if you want to use the command line tools or then this interface. It's just if you are using the plugin, you need to clone and configure your credentials on the command line. Right. Okay. So let's wrap up. That clock is a bit lagging behind, so it's almost 1:45. Just as a reminder that this is kind of now seems like a bunch of command line codes that you need to memorize. So here they're discussing that Git is so cool. So how do we use it? The bottom line is that as long, of course, like to start with, you want to submit your exercises to GitHub. if something goes wrong and you're super confused, you can always do the same thing that we did in exercise 1. So you can download your notebook file and commit on the web browser. That's totally fine, but we hope that you take this opportunity to actually commit things using either the command line tools or then the plugin. Yep. And super briefly, exercise 2 is about practicing this GitHub pipeline. So that's part of the job. You will do the exercise by modifying this existing Jupyter notebook, so you don't need to create any additional files. We have 3 problems. You start by cloning the exercise. Then you will, in the first problem, make changes to the code until it doesn't give you any errors. So the point is to start running the code cells, you'll get errors, and your job is to get rid of the errors so that the code works. Using the skills with lists and indices from this week. And then problem 2, you need to apply a bit more your skills with lists and indices. So that's the same thing. And then problem 3 is just about practicing Markdown and practicing more with Git. So you have a few answers, you need to modify Markdown, add an image, and so on. Yep. Maybe final note on the exercise. I'll just show quickly my own copy of it. Let's close that one from there. So you'll also find some of the code cells with these weird, not implemented error lines. We are using this kind of semi-automated grading system. And the point here is that it will give you an error. So you can just start working by deleting the line that produces the error, and then you can continue. Okay? So let's stop here. If you have questions, we will stay here with Dave and Lotta to answer, and Thursday, Friday, practicals. So thank you for today. Yes, please. Pikku hetki, mä koitan. Dave, how to shut down the live feed? Mene pois YouTube-livestä. Stop streaming, yeah.